These are the topics that we are going to cover today. The word itself is very interesting to understand into the frequency of that particular observation. So this is another method which you are using the arithmetic mean summation of effects, that is frequency. There is some observations that are also being seen. What is the weightage that we are getting? Median is the positional value, L plus N divided by 2. Good morning and welcome to my second session on Chapter 5, Measures of Central Tendency. In the last chapter, we were trying to discuss about arithmetic mean, median and mode. Now, the first factor is that we have only seen about the arithmetic mean. We are now going to see about median. Before that, we will also see some of the methods that have been discussed in arithmetic mean. And then we will go to another important function called as median, and that would also try to make us understand the importance of statistics in terms of application when it comes to economics. So quickly moving forward, these are the topics that we are going to cover today. We're going to see the step deviation method. We're going to understand the discrete series method, quite an interesting one. Assumed mean method, the formulas for that, continuous series, weighted arithmetic mean, and then we are switching to the median and the median formula. Now, if you have a quite close look at the topics, at the levels that are being given here, these are all quite connected topics in statistics. Very important, will help you to score marks and will also help you to understand the concept better as in statistical application in economics. So quickly moving forward, we have the step deviation method. The word itself is very interesting to understand. Step deviation method. So are we deviating? Are we just going one step further in order to understand? Let's have a look into it. The calculations can be further simplified by dividing all the deviations. Now you're going to divide all the deviations, not one or two. There are going to be multiple deviations that are going to come here, taken from the assumed mean by the common factor C. So I just want you to remember this common factor C. Now, how is the application of this step deviation method? Now, for example, if you are going to do an assumed mean problem which has got multiple deviations, which has got multiple factors altogether, then we start coming into the step deviation method. Why? Because if you see in statistics, there are many a times when you will get multiple sets of data, where you will get multiple organizations or activities itself happening in the data factor. So at that point of time, we take the step deviation method. So the step deviation method will help you to calculate, keeping a common factor C and dividing all the deviations that you are taken together. This is a very important factor or an important theory that one has to understand in statistics. This is not going to be simple. Why? Because we are not just going to take one deviation, we are going to take multiple deviations. And this kind of method you can see when you are taking a census report, or when you are taking a mark survey, or when you are taking a performance survey. All those kind of areas is where you will be able to understand the importance of the step deviation methodology altogether. Because the step deviation method is a very important concept. It will try to understand where all the deviations are coming in terms of statistics. Moving forward, we have the discrete series. The word discrete itself to say that it is something that is quite natural, and it is a direct method in which the frequency against each of the observation is multiplied by the value of the observation. So each observation, let's say that x value is equal to 5, the frequency for this is 6. So now what we are going to do is that multiply it. 5 into 6 is equal to 30. So that's what we are going to do here. The values so obtained are summed up. So we are going to add up all those values, divide by the total number of frequencies. So I'm going to total up the frequency value and finally divide it. Now this discrete series is on the direct mode is something where you have a random set of numbers that is being thrown across to you and you need to calculate the arithmetic mean out of it. So it becomes quite interesting for all of us to understand, to observe and to find out where is this discrete series method being used. Now for example, many a times when you take the class mark, a performance in a particular subject, you might see that students tend to score on a particular pattern. Let's say in a class of 100 students, there might be 50 students who have scored 60 marks. There might be some 20 students who have scored 80 marks. There might be some 30 students who have scored 40 or 55 marks. So you will be able to understand that there is a trend that is getting evolved. So using that trend, using the pattern, you will be able to understand discretely there are values that are being given and the frequency level for each is being seen here. So that is where I would like to use a discrete series direct method. You are just going to multiply the value into the frequency of that particular observation and try to sum it up and get the final value here. So moving forward, we are also going to talk about the assumed mean method. We have spoken about this in the last chapter, in the last series altogether. Now in this session also, we are going to talk about the assumed mean method. As in case of the individual series, the calculations can be simplified. That word, can be simplified. That means we are going to make the statistical data even more simplified, even more understandable to you by the assumed mean method as described earlier, because we have already spoken about this method in the session 1 where we have used for a simple modification. In that session, in that problem, we had tried to do with just one simple modification value. Since the frequency of each of this item is given here, we just multiply it with the deviation factor and then the frequency into to get the value FD. Because if you have seen it in the last session, just a quick recap, we would have find out the value of the assumed mean that is given by the letter A, plus we would have added up summation of FD, that is your frequency into deviation value, divided by n, that is the observations that have been seen. So using this method also, you will be able to arrive at the arithmetic mean, which is very, very important, interesting also. So this is another method which you are using the arithmetic mean by using an assumed factor and arriving at the answer. Now moving forward, we have the step deviation method again coming up, where I have spoken about this using the common factor C. Now what we are going to see here, or what we are going to observe, are the formulas that are being told. In the direct method, if you have quite an observation here, it is very, very simple. We are just going to do summation of fx, that is frequency, into the variables, that is the value, and divided by the total frequency. So if you just multiply f into x, the frequency into that values, you will be able to get the summation into that divided by the total frequencies that are being observed. But the moment you start moving into the assumed mean method, this method is going to be a little bit challenging. Why? Because you need to assume a value and then start deviating. That means statistically, one thing that we have to understand in economics or in any other factor, there are certain times when you do not get the exact data. You do not get the exact value. So what you tend to do, or what you tend to put forward, is that you assume a value. You assume that using this particular value, using this particular factor, let's start arriving towards the result. So that is where you are using this. So that is what I called as the assumed mean method, keeping A as the assumed mean. Then moving forward, summation of FD, summation of the frequency value into the deviation observed here, where D is equal to x minus A, as I have told you. D stands for deviation, x stands for your number of observations minus the assumed mean, and then you will be able to use this formula. Now the new formula that we are going to learn today is the step deviation method, a very important and an interesting factor. Just have a quite close look into the formula. It almost looks same like that of the assumed mean, except for the factor. Now we are going to bring in the common factor called as C that we have discussed here. So the x bar, that is summation here given by the assumed mean, plus summation of fd divided by summation of f. This is pretty much common that you have seen here, and plus, now you're going to multiply that with the common factor C. Now D is equal to x minus a divided by c. So in addition to the assumed mean method, you are just going to divide it by c. That is the common factor. So the number of deviations you are getting it, you are going to divide it by the common factor in order to understand the final value here. So that is the only change that you're going to see in a difference from assumed mean to that of a step deviation method, because the number of steps that are involved, the number of values that are involved, that's going to be divided by that common factor in order to arrive at a particular value. Now moving forward, the continuous series. Now many a times you will see that the data itself has got a continuous series. Here the class intervals are going to be given. That's the most important factor. When you talk about a continuous series, which means which is running at a particular angle, at a particular frequency, there will be some class intervals that are going to given, so that the process of calculating arithmetic mean in the case of continuous series is same as that of discrete series. So that is the most important factor. Why? Because you are being given a class interval. Let's say from 5 to 10 there is a value, from 10 to 15 there is a value, 15 to 20 there is a value. So automatically you are able to see that when the data is running in a particular manner, in a particular series, there is some observations that are also being seen. So some frequency values are also being noted against that particular series. The only difference is that the midpoint, this word is very important. Midpoint, you need to calculate the midpoint of the various class intervals are taken. So when I say the midpoint, that is nothing but 10 plus 5 divided by 2. So that is 15 divided by 2. So my midpoint would be 7.5. So I need to take the midpoint because that's the serial point, that's the point where I need to arrive in order to understand in the continuous series the arithmetic mean that we have to derive. We already know that the class intervals might be exclusive or inclusive, which means they are either exclusive. Now you see here they are all on a series foundation here that keeps on going, or it might be inclusive in nature or of unequal size. So we are not really going to bother about that factor too much, whether it is running exactly pin to pin, dot to dot. But what we are going to see is that this series that called as a continuous series, if we have to find out the value, what we are going to see here is that we are going to use the same discrete methodology formula, plus we are going to find out the difference, that is the midpoints that are going to be taken in, and then we will be able to calculate the continuous series arithmetic mean altogether. Now moving forward, the weighted arithmetic mean, this concept is very important when it comes to the statistics, especially the application in economics. Try to do this concept as by using the weights, which means we are going to give a weightage, we are going to give a value to certain factors, and using that we are going to arrive. Now for example, in a day-to-day life, let's take this example here. You are going to buy mangoes and you are going to use a weightage for that as W1. Similarly, you're going to buy potatoes in the market and the budget value that is being given is W2. Now, the weightage for mango here is W1, which is going to be multiplied with price P1. So you would get the value as W1 P1. Now you're going to do the same thing for potatoes. The weightage is W2, which is going to be multiplied with price P2. So the value here will be W2 P2. So like this you can do for n number of values, n number of variables in the series. What you will be getting in the final is that you will get an entire series of value, that is W1 P1 plus W2 P2. Like this you can do for Wn Pn, and finally you can divide the entire factor by the common, the total number of observations, and you can see that what is the weightage that we are getting for each and every product that you buy in the market. This is very, very important. Why? Because in economics, when you try to understand a simple complex factor called as consumer price index, at that point of time, the weighted arithmetic mean will definitely come into picture. We will try to understand this consumer price index in the coming classes, no doubt about it. But then these are the application, the real-time applications that you will see when you are going to apply it using statistics in economics. So moving forward, median. This is a very, very important and an interesting topic that we are going to see today. Median is the positional value. This word I want you to remember, positional value. It is not just any value, but it's a positional value of the variable which divides the distribution into two equal parts. That means it's going to divide the series into two equal parts. One part comprises of all values greater than or equal to the median value, and the other part comprises value less than or equal to it. So at some point of time, let's say that if you're going to have 10 variables and if you are asked to find out the mid value, the middle factor altogether, the median comes into picture. Median is a very, very important factor which will divide the series either into greater half and lesser half, or it will be equal to it. But then using that only, we are going to find out the positional value of data for any given series that has been presented to you. Now the median is the middle element. That's the most important keyword that we need to take here. Middle element. So that's the mid value. That is the point that we need to concentrate when the data set is arranged in the order of magnitude. So it might be in ascending order, it might be in descending order, it might be in any random order, but that middle value, that positional value, that factor that we are going to decide using the median is the most important characteristic for any statistical data that is going to be presented to you. So please keep in mind, moment they ask you about the question called as median, you need to find out the middle value that has been given to you. Now moving forward, the formula for median. Now this is one of the important things. Suppose when you have the median as an odd number series, it is easy for us to find out the value. Suppose it is an even number series, we need to find out this using this formula where L is the lower value there, N is given as a total observation minus the middle value frequency into the common factor. I just want you to remember this formula, L plus N divided by 2 minus M divided by F, that's the frequency here, into the common factor. So that will be able to help us in terms of finding out the median. This formula might initially look confusing or a little bit complex for you, but then you don't have to worry. Why? Because all you have to just use this formula where you will be getting the values. Just fit in the values here in terms of the problems that is being given to you, and you will be able to get the answer as quick as possible. So with that, we try to come to the conclusion for today's session, where we are just going to understand the factors here in terms of the lower limit of the median class. We are also going to talk about frequency in the formulas. C stands for the width, N stands for the total frequency here. M is the cumulative frequency that we have talked about. So this is the explanation of the formula before I try to conclude for today, where L is the lower limit, F is the frequency, C is the common factor where I told the width of the median class, N stands for the total frequency, and M is the cumulative frequency of the class. So I want you to remember these factors, L, F, C, N and M. So one more time, L is the lower limit, F is the frequency, C is the width of the median, N is the total frequency, and M is the cumulative frequency. All these values will be available to you in the problem itself. All you have to do is pick up those values, fit it into the formula, and you will be able to get the answer. So no need to worry, this is not a big confusing mathematics or it's not big challenging thing to you, just put in the values, automatically you will be able to get the answer. With that, we come to the conclusion of today's session. I hope and believe the session was interesting, informative and educative to you. In this session, we have tried to understand some more methods of mean, and yes, we have also tried to understand a new concept called as median. In the coming sessions, we will also understand how to solve problems in median and also a concept called as mode. Until then, goodbye and good luck. Please stay tuned, stay blessed and stay enlightened forever. Thank you once again for joining me today.